Hello everyone, welcome to the session. In this session, we are solving a question from geometry from the recent mock test practice sessions. And this is a difficult question, so this will take some time. So don't worry. If you are really interested in, let's say, getting a very high percentile in your mock exams or in your actual CAT, I would really encourage you to pause the video and try out this question. I hope everything is okay. Now let's read it. In this question, they have said that in the following diagram, S is a point on the side QR of the triangle PQR. So this is a triangle PQR. S is a point on the side QR such that QSR is a straight line. There are some dimensions given like PQ is 24, QR is 36 and PR is 20. And then there are in circles of the triangle PQS and PRS drawn such that they touch each other. Question says that what is the area of the triangle PSR? So we need to find the area of this triangle. If we can find the area of this triangle, everything will be sorted. Now, what is it that we will be using in this question? So I have taught you in this classes that this is going to be the classic case of a triangle and the CVNs. Okay, so suppose ABC is a triangle in which, let's say, AD is a CVN. CVN is basically a line from the vertex to the other side. Okay, if it bisects the other side, we call it a median, but this is not doing anything like that. So by the very virtue of this AD line, the BC line gets intersected in the ratio x is to y, and because of that, the ratios of the areas of the triangle ABD is to ADC will also be in the ratio x is to y. I'm not saying that the actual values will be x and y, but the ratios will be in this thing. Okay. Having said that, now what you need to consider is that can we calculate the entire area of the triangle? Yes, because Heron's formula we can use and we can calculate. Let's just make some sense. So this is 24, this is 20, and this is entirely 36. There are triangles, there are circles also inside the triangles, and the circles is touching the triangle. So one thing that you can see is that there is a property of circle that from an exterior point if you draw a tangent to a circle, the tangents will be congruent, okay, from the same exterior point. With that logic, I can do this. I mean, I don't want to unnecessarily put too many variables, so I will say that this length, okay, this length is x, so then this becomes 24 minus x, okay, because the sum it has to add up to 24. So this will also be 24 minus x, and this will be x, this will also be x, so this length will be 20 minus x, this will be 20 minus x, and I don't know anything about these two lengths, right? So what I will do is at this point I will assume another variable y. Let's see for the length QR what we have. So for the length QR we have 24 minus x plus 2y plus 20 minus x is equals to 36. This is the total that is given. So this is basically I'm basically doing some shuffling in my mind. This will be 2x minus 2y will be 44 minus 36, that is 8. This implies that x minus y comes out as 4. Great. What about the area of the triangle? The area of the triangle can be calculated with the Heron's formula. For that we need the semi-perimeter. Semi-perimeter is nothing but the summation of all these sides divided by 2, that is going to be 24 and 36. So 50, 60 and 80. 80 by 2 is 40. Semi-perimeter is 40. Let's calculate s minus a. This is 16. S minus b is going to be 4. S minus c is going to be 20. Okay. So from the Heron's formula, we know the area of the triangle PQR will be root over s into s minus a into s minus b into s minus c. Okay. This is going to be equals to 40 into 16 into 4 into 20. Now see how I will do this. So I need the value, right? So what I will do is I will take 2 outside, I will take 4 outside, I will take 2 outside, and I will take 10 outside. Okay. 4 and 2 and 4. This is 2 and a 10 outside. That means a root over 2 will be inside. Okay. So this is going to be how much? This is 160 root over 2. This is the area of the entire triangle. Now, I know the entire triangle. If by any means I could just find out, that um, uh, the length of one of the sides. Okay, length of one of the sides, this side or this side, I can use that idea that I just told you over here. So how do we do that? In an exam condition, this might be a little difficult, but over here you see, I will have to use this expression, x minus y is equals to 4. Now if you play around with your numbers in a little logical way, na, you will get x plus y is equals to something, and your life will be easier, but nonetheless you will get the value. So just pay attention to this part. Okay, just pay attention to this part. What is this? This is 20 minus x plus y. Hello, can you see that? I will use a different color. So just this much. This is 20 minus x plus y. 20 minus x plus y. Okay, can I write it like this? 20 minus, if I take minus common, this will be x minus y. Do I know the value of x minus y? Yes, 4 from here. So this is 20 minus of 4. So just for this much length, I have been able to calculate that this is 16. If this much is 16, the other has to add up to 36. So this will be 20. So the ratio is nothing but 5 is to 4. 4 5s are and 4 4s are, right? So if you have understood this from this methodology, 9 part corresponds to 160 root 2. 4 part will correspond to 160 root 2 by 9 into 4. 16 4s are 64 root 2 over 9. This should be my area for this part. Do I have an option like that? 640 root 2 by 9? Yes. Option number C is that. And this is how we solved it. Okay. This was a very interesting question, a difficult question indeed, but that's what we are learning in the mock test series, right? Thank you.